Alright, so let's also do a couple more 2D problems. So here we've got this bracket, L-shaped bracket here. It's got supporting two weights here. And everything here is going to be supported. It's got a hinge here at C, so allows rotation, and what we call a control cable from A to B. So I guess you could kind of spool in this cable and sort of cause the thing to rotate up or down if you wanted to. Anyways, we want to find out, in this situation, find out what the tension in the cable is and the reaction at C. Alright, so here we go. Determine the tension in the cable and the reaction at C here. Okay, so we had the diagram already, so I'm gonna place that with the free body diagram. So we have the bracket. We've got the two loads, the 240 Newton loads. We've got the tension from the cable. So I've already broke that up into its X and Y components. And we've got the X and Y components of the reaction at C. So, first things first, what I'm going to do is I'm going to take a moment about C. So, that's relatively simple. And again, we know that that's going to be equal to 0. So, the moment at C is equal to 0, which is equal to this force times this, and that's a negative moment because that'll be acting clockwise. Same thing for this one, except we've got a 0.8 meter span between there. And we've got our Bx here, so the x component of the tension in the cable, times this 0.18. That didn't really show up too well when I scanned it. 0.18 meter span from here to here. So that'll be a positive, because again, taken about here, that's causing a positive rotation about the point here. So relatively simple to solve for Bx given that. We got 1.6 kilonewtons. So the dimensions of that dimensions of the bracket here, 0.18 meters, 0.24 meters. That actually ends up being, not too shockingly, a 3-4-5 triangle. So that means that we can basically, knowing Bx, we can just solve for By, because it's going to be 3/4 of of what we solve for Bx as, because the y the y component portion here, that's proportional to the that's the 3 in our 3-4-5 triangle, as opposed to the x, which is our 4. So we can solve for the By there as 1200 at 1.2 kilonewtons, which makes it relatively simple to solve for our total tension as well. So again, we got that times 5/3, or times 5/3 to give us 2 kilonewtons, or take that, square it, plus this squared, take the square root, ends up as 2 kilonewtons. That's the point of the 3-4-5 triangles, is that they show up in problems a lot because Pythagoras' theorem gives you a nice round even number. Next thing to do, well, we've already taken a moment, so that's one equation down. Let's use up one of the other equations. So total of force in the x direction is going to be equal to 0. So the only forces in the x direction that we have here are the reaction at C and the tension from Bx. So that minus that, and again, is going to be equal to 0, because it's that minus that, because I already had the orientation set in a free body diagram properly. Or at least the orientation of the tension in the cable was set properly. This, if this thing ended up being negative, then obviously that would have flipped. But it doesn't, so our Cx there is going to be equal to our 1600 newtons, or 1.6 kilonewtons. And then, well, we've got one more equation left. Let's use it. So we got these total of the sum of the forces in the y direction equal to 0. So again, negative by minus the 240 minus another 240 equals cy. So cy, add these terms to the other side of the equation, solve for cy. It's 480 plus 1200 is equal to 1680 newtons. And again, that's positive because I guessed the directionality of that support right when I did the free body diagram. Yay me. That's it. That's all.